Show that of all the rectangles with a given perimeter, the one with greatest area is a square. All right, so let's P is our perimeter, which is equal for rectangle with the length x and height y. So P is equal to x plus 2y. And area is equal x times y. So let me write down length is x, height is y. Okay, so I'm going to express this perimeter and area as a function of x. To do as a function of x, I have to substitute replace y with x, the area. So what I'm going to do, first I need to find out y from this perimeter. Okay, 2y is equal p minus 2x, right? And divide it everywhere by 2. I'm going to get y is equal p over 2 minus x. Okay, since I said we are going to represent the area as a function of x, so I'm going to make y is gone and replace y with x, which is going to be x times p over 2 minus x. Okay, and from here, a is equal p over 2x minus x squared. Okay, let's identify what values can have the x. So if I write down negative somewhere here, negative x squared plus p over 2x is equal 0. Now let's find y also, right? Here is our y. Y is equal, y is equal p over 2 minus x. Let me write down. Y is equal p over 2 minus x, which means it's equal p over 2 minus p over 4. And it's going to be equal p over 4. And the maximum, it's going to be p over 4 and p over 4. Exactly same information we got in calculus. So this is a proof because an x and y are the same. That means we are dealing with square. And because the square represent the maximum and in calculus, and with method of optimization of quadratic function, then we can insist that square is the maximum for the rectangle with given perimeter. Okie dokie. Let's find the limit of x. So I'm taking negative x out. Color. Pi over 2 negative minus x equals 0. So either x is equal 0 or x is equal half a pi, which means x has to be between 0 and half a pi. Okay. Next, we are going to use first derivative test that will help us to find critical numbers, increasing, decreasing intervals, find relative extrema, maximum and minimum, and global accordingly. So, and that will be our maximum area that we are looking for. So, let's take derivative. I'm taking derivative of the a by dx, and that is equal, it's going to be p over 2 minus 2x. Okay, so to use first derivative, we need to assign it to 0. P over 2 minus 2x is equal 0. And from here, x is going to be equal P over 4. And in fact, practically at the point of P over 4, this derivative become 0. And in fact, it changes sign from positive to negative as x will increase through P over 4. You can take some value less than P over 4, greater than P over 4. Okay, so let's say if this is our, you need to test, if this is our P over 4, you take less, it's gonna be positive if you test it, and if you get the greater value than P over 4, you should be testing it as a negative. So smaller than P over 4, you can take P over 5, let's say, or P over 6, and less you can take P over 3, because don't forget limitation is P over 2, okay, and it's less than, so you don't take P over 2, you just take less than P over 2. Okay, that will be your test. And based on first derivative, if the testing is changing from positive to negative, that means that critical value is your maximum, is your local maximum, which means is P to 4, P over 4 is your local maximum value, is the local maximum value of the area. And A is equal f of x, f, since our f of x is quadratic equation, right? Where is it? Right here. Is a quadratic equation, then actually we can say it's a global maximum. Okay, let's see. When x is equal P over 4, then how much is y? Let's find y. Y is going to be P over 2 minus P over 4. And it's going to be equal P over 4 as well. And I plug it right here. Y is equal P over 2 minus x. So that implies that x is equal P over 4 and y is equal P over 4, which means we have square, and since we just proved that it's a maximum, right, value based on first derivative, and you have to go through test, you plug in the test and see if you get positive or negative, right? And this is how you're gonna get your maximum for the rectangle. In other words, for all rectangles of a given perimeter P, the square of side length P over 4 is the greatest area. Greatest area. Okay, now instead of calculus, I'm going to use method of optimization for the optimization of the quadratic equation or function. Since we have A is equal, let me use different colors so you will see. Well, okay. A is equal P over 2x minus x squared. if I rewrite, we will have negative x squared plus p over 2x, and since we don't have c, I'm just adding 0, right? Okay, and this is gonna be, I'm writing down 0. What do we have? We have quadratic equation where coefficient a is equal negative 1. It's right here. Okay, when coefficient is negative 1, then our graph is gonna go down, right, like this, right? And if it's going down, then this point is gonna be our maximum, right? Which is, we are going to get the maximum area this way. So let me solve it. And for this type of equation, we know that this vertex, the value of x is negative b over 2a. Negative x value of x is negative b over 2a, and y is going to be f of negative b over 2a. And this is our vertex, values of our vertex, which is maximum for going down parabola, right? So what do we have here? X for vertex is going to be equal negative. So my b is, let me complete here. B is here going to be p over 2, right? And c is going to be equal 0. Let me write properly. So b is equal p over 2, a is equal negative 1, c is equal 0, right? Ax squared plus bx and plus c. Okay, so x is equal negative for the maximum of vertex, negative b over 2a, which is b is negative, b is p over 2, right? And we are dividing by 2 times a, 2 times negative 1. And this is going to be equal, if you divide, well, negative is become positive, p over 2, dividing by 2, we get p over 4. Precisely what we had there. Now let's find y also, right? Here is our y. Y is equal, y is equal p over 2 minus x. Let me write down. Y is equal p over 2 minus x, which means it's equal p over 2 minus p over 4, and it's going to be equal p over 4. And the maximum, it's going to be p over 4 and p over 4, exactly same information we got in calculus. So this is a proof, because an x and y are the same, that means we are dealing with square. And because the square represents the maximum, and in calculus and with method of optimization of quadratic function, then we can insist that square is the maximum for the rectangle with given perimeter. Okie dokie.